Okay, so we've got a situation where a water tank is being filled at a constant rate. The water tank has sides of x and 2x, and the depth of water is h. Okay, so we've got that situation. You see, the tap's been left on, and the water tank just keeps changing its height depending on time. What I'd like you to do is just have a quick think about what these rates of change actually represent. So let me move my pointer. So I've got dv over dh, dv over dt, dh over dt. So just pause, have a think what they actually mean. How would you write those down as words? Okay, so we know they're all rates of change between two things. So let's look at this first one. The change in V, which is the volume. Okay, so the change in volume over the change in height. So how does the volume change over height? So that would be the rate of change of volume as the height changes. Now the other two are to do with as time changes. So the change in volume over the change in time. So as time passes, how does that affect how quick the volume is going up? And finally, the change in the height over the change in time. Okay, so how long does it take to reach 1 meter, 2 meters, and so on? So that is the change in height. So depending on the wording means that sometimes you have different rates of change formula. And you need to be very clear when you read a question, what's the appropriate variables to use, and make sure you get them the right way round. It's absolutely vital that you don't just write them either way round. Okay, it's important to get them the right way round. Okay, so yes, the rate of change in height over time. So as you can see, all these rates of change just here have something in common. So we've got this one here that's connected by its volume. These two here, that one and the final one, are connected by its height. And these two here are connected by time. So they're all connected with each other. But let's say, for example, you want the change in volume over the change in height. That's your goal. You want to be working that one out, that rate of change just there. But you don't have that, but you do have either one of these given to you. So maybe you've got the rate in volume over change in time, and you can calculate the change in height over the change in time. So you've got these two, but you don't have this one to work out. Well, what you can do is you can actually calculate that by connecting these two together, and you can connect them using the chain rule. So for example, if I had the change in volume over the change in time, and I had the change in height over the change in time, I could substitute those two in this formula. I could do a bit of rearranging by maybe dividing by this, and that would allow me to work out my change in volume over the change in height. So if I'm given any two, or I can easily calculate one of these and then substitute it in, then that will allow me to work out the third rate of change. This is what we mean by connected rates of change. If you've got two rates of change, you can put those together to make a third rate of change. Okay, so in your notebooks then please, just to have a go at writing this question down. The area A of a circle is increasing at a constant rate of 2.5 centimeters squared per second. So it's a case of making sure that you can read that language per second. So I've got a change in area over a change in time right there. Find the rate at which the radius of the circle is increasing when the area of the circle is 4 centimeters squared. Okay, so I'll pause, give you a chance to write it down. And let's have a quick go. So the first thing I've noticed is that first thing I was just talking about. I've got, from that first line, the area A of a circle is increasing, so it's positive, at a constant rate, and it tells you the units in there. So the area of a circle is increasing. Now that could be against anything, but the actual formula here is telling you it's to do with time. So it's increasing at 2.5 centimeters per squared every second. Hence me getting that one. Okay, what else do I know? Well, I know the area is pi r squared because we're talking about a circle. So that's GCSE knowledge right there, but the examiner expects you to remember everything from GCSE as well. So because A is a circle, I know that I could write A as pi r squared. Okay. What can I do with that? Well, because I've got A, I could actually work out the change in area of the change in R, change in the radius. So I could actually look at that as a rate of change formula. Okay, as I increase a radius of a circle, how does the area increase? So I could write it like this. The change in area over the change in radius is equal to 2 pi r. It's exactly the same as the circumference, interestingly enough. So once I've got that, what I can do now is I can also make use of the a equaling 4 to calculate what the radius is. Because if I know what if the area is 4, right, although it's not asking for the actual answer to what's the radius, I'm going to make use of that in a minute. So find the rate at which the radius of the circle is increasing, not what is the radius, but the rate that the circle is increasing when the area of the circle is 4 centimeters squared. So I'm looking at when is the rate changing. Right, so what can I do now? Well, I can certainly fill that in. I can work out what the r value is. So r is 2 over root pi, keeping it in exact form. And we're asked to calculate the rate of the radius changing over time. Okay, right, so why does that help me then? That means I need to work out the change in radius over the change in time. Okay, so if I've got dr over dt, that's what I want to work out, but I don't have dr over dt, but I do have dA over dt and dA over dr. Noticing that when I fill this in, I always make sure that these two, right, are the same. So they can cancel out. The dr and the dr cancel out. So I should be looking at these and thinking, right, I want dr over dt. Maybe I can get dr from that bit if I flick that round. Okay, so I get dr over dA. And in fact, if I just multiply by that, the dA's might cancel out and therefore I'll be sorted. Okay, so it's trying to manipulate these two equations to get dr as a numerator and dt as a denominator. That one's sorted. That one could just be done on the other way around. Or you could just write down any one you want and just then fill in these bits and then hope it's the same ones as what you've already calculated. Okay, so what happens next then? So I can fill it in. The rate of change of area over time was given to us 2.5. The change in area of the change in radius is going to be 2 pi r, but I know that the r value is 2 over root pi, sorry. The only thing I don't know is dr over dt. So just a little bit of rearranging, and I know that then dr over dt equals 0.35. Okay, so what I'd like to do is just have a go at the exercise on page 327. So there's some good rates to change questions on there, but also the exercise on page 365 also involves some connected rates of change for you to have a go at as well.